All right, hi there. So we are on our 2.1, 2.2, the practice test 2. Your heading will look a little different. It will say practice test 2. So this one is a little bit closer to what we're going to see on the common assessment. And I want you to try these first on your own each time. So if I read the problem, maybe you pause it and try it and then check it. So kind of treat it more like if you're taking the test and then using this to check your answers. Because afterwards I will also walk you through, if you pause the video in the correct spots, I'll end up walking you through all the answers. So this first one, learning target, again, we want to make sure we know where we're at, so we're on the correct notes. You should have your 2.1 notes out. There's a couple good sheets in there, especially the ones that have these vocab terms, or postulates or theorems that we need to know. So number 1 says, we are going to, first of all, look at this diagram over here. And then we want to name a pair of consecutive interior. And hopefully you remember by now, consecutive interior are the only ones that are not like the others. They form the straight line. So I like to always write that line there just so I know. They're the ones that are a little different. They form a straight line. When we get into the next target, we need to know they also will add up to 180. But for right now, just identification. So go ahead and look at this figure and try to see if you can find 2 consecutive interior angles. So remember, they need to be on the inside. And you know what I like to do is I like to first make sure that my parallel lines, or the 2 lines that are running one way, are highlighted so that I can see interior and exterior angles. So that will help me. So if you put interior, you would have had either 4 and 5, or you could have had 3 and 6. I'll put 3 and 6 underneath, just in case. Those are both correct answers for consecutive interior. Now let's go ahead and look at a pair of corresponding angles. Now remember, corresponding are if you take the 4 angles here and you were to place them or slide them on top of the other set. So it looks like the 1 and 2 would be in the 5 and 6 spot. The 4 and 3 would be in the 8 and 7 spot. So just if we were to take these and plop these right down on the other side, that's what corresponding means. So go ahead, take a second, see if you can figure out the corresponding angles. So if you put, there's quite a few answers. So again, if you could have put 1 is in 5's spot. There are so many other angles. I'll just show you a pair of inside, outside. So then we have to make sure 2 corresponding are going to be on the same side of this transversal. You cannot pick ones that are like 1 and 6 for right now. We want to make sure that when we slide them down, we're using that. So also then you could have picked 4 and 8. That would have been another one. Oops. I just looked at the set of corresponding on this side. If you looked over here and you put 2 and 6, that works. 3 and 7, that works. Okay, so those are some possible answers. Make sure you understand why, though. Okay, the next one, we have alternate exterior. And the important part is we're looking at stuff on the outside of the parallel lines. So you cannot look at what's inside here. So alternate exterior means they're going to not be on the same side of the transversal. They're diagonal. Remember, if we were to draw an imaginary line, which 2 would be diagonal from each other? So exterior means 1, 2, 8, and 7, and then alternate means they're diagonal. So as you can see, the 1 and the 7 are diagonal from each other. Those are alternate exterior angles. And then you can also see the 2 and the 8 are on the outside, and they're also diagonal. So you could have put either one. You could have put 1 and 7 or 2 and 8. Just have to be careful. You make sure you choose the ones on the outside. And then the last postulate that we really worked on a lot, the alternate interior angles. So I want to make sure you understand alternate again is that diagonal, interior, our inside. So if we're looking at that, I kind of just like to make sure I either give you guys sticky notes or I like hide them. Interior is right here. It's what's on the inside of the two lines. So you can only look at these for alternate interior. And remember, alternate means diagonal. So they're going to be opposite sides of the transversal. So 4 and 6 are diagonal. So those are alternate interior angles. You can also see 3 and 5 are diagonal. So those could be your sets. So alternate interior and alternate exterior. Just have to make sure what you're looking at is correct. So I have, again, 3 and 5. I could have had those. Or 4 and 6. Interior, okay? So again, consecutive interior are totally different because they're the ones that form the straight line. So those are our vocab words. They're also the postulates that we need to know to prove things in 2.1 and 2.2. Also going forward, okay? So hopefully you got these right. Let's look at the next one. Again, we're going to try to do the same thing. We're just going to indicate some relationships. Here we go. So our choices, referring to this diagram, we're going to say whether they are skew and ignore the numbering. Yours will be correct. But basically, we're just going to make sure, and I got rid of none of the above. We're going to do skew lines, which remember are not parallel and they don't touch. Because touching would be then the perpendicular. Parallel are they don't touch, but they're exactly the same distance apart the whole way. They will never end up touching. They're just straight lines that go the same way. Perpendicular, as you recall, they have to touch. So two perpendicular angles form that L right here. So I'll make that part sink a little bit thicker. And the 90 degrees is the important part. So remember, that could be the top with the side of a box. It could be the bottom with the side of a box. Usually that's how we see perpendicular. All right, so I want you to try these after I read them and then pause the video and check your answers when you're done. So it says indicate the relationship. Again, these are the relationships: skew, parallel, or perpendicular. So indicate the relationship for the pair AB. I'm going to do AB, which is right here, and EF, right here. Okay, so again, I like to have the highlighters. It helps me see. So hopefully you would pause it, and then hopefully you put they are parallel, or the letter B. All right, indicating the relationship. Now for AD, so AD is right here, it's the orange, and CG is here. So looking at them, I can see they don't go the same way, so they're not parallel. And they don't touch. What that means is they have to be skew. So we would put A. There's no symbol for skew, or else I would have put it. Okay? All right, so that's target 2.1. Using the vocab to just find the angles. Again, using the vocab to find the angles. Now we're going to look at the 2.2 target. So you'll want to have out your note sheet. This is where we apply a lot of it, and we have angle measures. So we have to find other angle measures. So we're still using the same vocab, but we're just answering questions a little bit differently because now we have numbers. So let's take a look. The first one, using the diagram. Again, ignore the numbering. Yours will be correct for the questions. It's the same diagram, but just different questions. So I am going to make sure I highlight my two parallel lines, and then just so I can see the difference, this is the transversal because it's cutting it. This just helps me visualize and see things. So with 7, if we are given that the measure of 3 is 85. So if I'm saying this one here is 85, find the other ones that would also be 85. So this is where we're going to look at to find the other ones. Remember, if you recall, we would do alternate interior angles, we would do alternate exterior angles, and we would do corresponding angles, or CA. Those are things we should know by now. These are the congruent ones. Remember how I said up here, all of them are congruent. So 2, 3, 4, they're the same measure except for consecutive interior. Those are the ones that add up to 180. So you also have a note sheet that says this thing, so, and has examples of them. So you got to keep that in mind when you're answering these questions. So this one is basically telling you to use these theorems to find the other 85s, because we know these are all congruent. So if 3 is 85, I'm going to use alternate interior. The one across from it diagonal would be 5. So angle 5 has to also be 85. That's just because of that theorem, we know this. So then if I have this one, first I have to actually alternate exterior. I'm not quite sure about the exterior yet. So let's go to corresponding. It'll be easier. So if I go and I take 3, 3's on the bottom, and I slide it down, 7 is exactly the same. So 7 would also be corresponding angles. It's telling me if this one, 3, is 85, the corresponding angle of 7 is also 85 degrees. And then, now I'm going to use the alternate exterior. So if you can see, 7 must be the same measure as its alternate exterior angle. So if 7 is 85, now the one diagonal from it is angle 1. So 7 and 1 are both 85 because of that. Oops, sorry, I should have put angle 1. Because of that theorem. So we don't need the degree sign. Sorry about that. So again, we used what we knew, those postulates or theorems, to figure out those 3 that are the same as the given one. Okay? All right, let's try number 8. It says, given that the measure of angle 1 is 64. So now we are pretending again. Brand new figure. So we're going to pretend this is totally different. If 1 is 64, find 7. So if you can already see, we know 1 and 7, just looking at 1 and 7, I'm going to cover the interior because I noticed they were both on the outside. So 1 and 7 are alternate exterior angles. They are alternate exterior angles. I'm going to put that as a side note to myself because that will help me answer it. If they're alternate exterior, that means they are congruent or equal. So if 1 is 64, angle 7 is also 64. It's that easy if you know the theorems. You're just picking theorems and then going to find the measure. All right, last one. If given that measure 3, again, so we're pretending this is a brand new problem, 3 is 73, and 6 we have to find. So if you notice, they are both on the inside, but they form that straight line. That's a straight line. So 3 and 6 form a straight line, which means they are consecutive interior. Consecutive interior, which means they add up to 180. So what we're saying is angle 3, which is 73, plus the unknown angle 6 needs to add up and equal 180. Or we can remember, when it's just numbers, we can just subtract 180 minus the one that we know, and that gives the missing one. So you can do it either way because it's going to end up being the same thing, the total minus. And again, doesn't equal 180. And again, so let's make sure we know, you have to know this is the special case. When they are consecutive interior, meaning they form that straight line, make sure you write this down, you remember it. This is usually the hardest one. You know you have to use that 180. That's the only time you're using the 180 to solve problems. So it would be 107, because if you looked back, if you were to plug it in, 73 plus 107 is that 180. Okay, so this was the special case. Now let's just do the back. All right, so this time I separated the diagrams so you can refer to them as new each time. So if we're telling you M and N are parallel, I'm going to go ahead, highlight my parallel lines. It says, what is the value of Y? So we're going to use some of the theorems to figure this out. So if I want to know Y, if you can tell, we've got 1 on the outside, we've got an 88, X, we don't know. It doesn't ask us to find X, so it's just an extra letter. Y is right here on the inside. So what we want to get to is either we need another inside angle so that we can do alternate interior or consecutive interior, or we need to do corresponding, because then we could also do corresponding would help us to get to that consecutive interior angle as well. So I would say the easiest, I would try to move the number, so whatever you're given, the rule of thumb is kind of, you try to move the number towards the one you're trying to find out. So if I notice, I can't do alternate exterior, but I can do corresponding angles. So I'm going to start with corresponding. I'm just writing myself a note. So if 88 is on the bottom on this side, 88 is on the bottom on this side. These are corresponding angles. I'm allowed to do that. If I know this is 88 and these are parallel lines, I'm allowed to put the 88 here because they are corresponding. And corresponding are equal or congruent. Now, most of you are able to look at it and see. We can actually see right here, this goes back to Unit 1, but these actually form a straight line. 88 plus Y, those are what we call the linear pair. So we do know we can actually take, this is 180. So we can do that, 88, that's a linear pair. And we're allowed to do that because we know the definition. I can take this 88 plus my Y, and that should equal 180 because it's a straight line. Or, the easier way, when we do that, we could just take 180 minus 88. It's the same thing, because what you would do is, to solve the equation, you would subtract 188. So then, hopefully you figured that out, and when you're checking this, you can see there could have been other ways that you figured this out. Y would equal 92. Okay, so there's some other ways. I could have done, if you notice, I could have done alternate exterior angles. So looking right here, if I forget what's on the inside, so not looking at what's on the inside, 88 and this one right here, those are alternate exterior angles. So I actually would have known this one's 88 as well. And then again, I could have done the 180 minus the 88. Okay, so there's a couple different ways you can get to it. But again, you have to know the postulates because that helps you move things around. All right, let's look at the next one. So if the two lines are parallel below, okay, we got two lines parallel, and it's cut by this transversal, we need to find A. So I can do a couple things. I like, you know how I said, I like to move the number to be near the variable. That's just what I do. You can move the variable to be near the number. It doesn't really matter. But I gave you some hints, corresponding then consecutive interior. So you could do that. So if I did corresponding, and I would do A is on the outside bottom here. I could put it in here. if I wanted to do 160, it's on the top. So these 4 angles on the top, 160 would actually go right here. And then you can also do, if A is the bottom, A would actually go right here. And what's nice about this one is this is a theorem that we have covered before, but is not as a multiple choice. We also know that we can use vertical angles. Remember vertical angles? They're equal. Vertical angles look like this. They're across from each other. They're what we call, sometimes we say they're kissing because they do touch, but they're across from each other. So this one is the same as this one. And then if we had 2 others, these 2 could be the same too. This one and this one. So we could use vertical angles as well. I think it's probably easier to use vertical angles because if you notice, if I moved this here, these 2 are vertical. Or this way, these 2 are vertical. So this one's actually really easy. A equals 160. It's the exact same thing. Vertical angles lets us say that. And then let's look at the last one. This looks more complicated than it really is. But again, we have a figure, we got a triangle, we have some things we know and some things we don't know. So it's just, again, stating we have 2 parallel lines. So I'm going to highlight my 2 parallel lines. Sorry, that's an ugly highlight. Let's make that a little bit better. Okay, and parallel. We know I'm using 160 again. This is 160 out here. If you think of it this way, because we have the parallel lines, and I'm going to think of this as the transversal. I'm going to ignore the other part for right now, but we will need to know the 90. This is, that box means it's 90, so it's going to factor in. So if I look at this and I were to take my 160 and bring it towards the A, 160 is on the top, so 160 would also go on the top here. Okay. I can also then, if I'm trying to find, I might want to extend this line too as a transversal. So I could actually use the pink as a transversal, ignoring this part. So now if you notice right here, I have 2 parallel lines, and this pink is the transversal. Okay. So we need to try to figure out what that A is. So we know that this here, this angle here, should be the same as, when we're looking at it, this angle here when we add them together. So I would have 90 right here plus A equals 160. That's how I get that there. So these 2 are vertical angles. That 90 comes into play. I have to use it. Okay? And then these are across from each other. So they're vertical angles. So that means vertical angles mean I can set them equal to each other. So this 90, which is that box, and the A, all add up to, and when I moved this, I just used corresponding, it adds up to the 160. So now I can solve. Minus 90, minus 90. So if you take 160, all you're doing is subtracting again. So getting there might be some of the problem. Okay? All right, so hopefully you did all right on this. You'll see problems like this on the test.